Okay, hello again, everyone. How are you doing today? Am I coming in loud and clear? Let me know in the chat, people. Let me know on the chat. Am I coming in loud and clear? Hello, Eric. William, yes. Hello, good to see you again. How is everyone doing? Week 8 is almost over. Can you believe it? The writing assignment is finished, hopefully. And guess what? You've got another assessment to do, the lab test 2. So in this morning's lecture, I asked the students, well, do you want some revision lectures? And they said, yes, we would love to prepare for lab test 2. So that is my aim today, to give you some revision and show you how Maple can be used and all sorts of stuff. So earlier today, I did a tutorial on the calculus questions from the practice exam. So I thought today we could talk about the algebra questions. Okay, so let me know what's going on. If you don't want to discuss that, then of course feel free to go to a different tutorial, or we might finish a little early as well, because there seem to be more calculus questions than algebra questions. I don't know why, but all right. So let me know what's going on in the chat, and let me share this practice exam with you. Okay, so here it is, people. So I'm going to do the all algebra questions. Okay, so let's resume. All right, so a classic example here. Find the moduli, the length, of the 5 roots of this polynomial. Okay. And enter a decimal approximation to the largest modulus in the box below. Your approximation should be correct to 10 significant figures. Okay, so we've got a polynomial. We want to find the moduli of the 5 roots and then choose the biggest one. Okay, so not too difficult with that one. Yeah, Denzel, I recorded the calculus one this morning. So it was at, what time was it? 2 p.m. Deeper understanding. Hang on. You just put that in the chat. Okay, so let's have a look at how we do this in Maple. All right, so let me go to my Maple window. Here comes the algebra. Okay, so what am I doing here? I'm defining a list, which is the roots to this equation, or this polynomial, I guess. Okay, and I've indicated that I want complex solutions. They're included. Okay, so the square brackets mean I guess I'm defining a list, a collection of things, and you can see down here that's one solution. It's real value. Well, actually, let me just press return. No, hang on. Let me start that again. Okay, so let me go up to the top, see if we can get this going. Maybe I've been logged out of Maple. Hang on. Hang on. Let me just go out of Maple and come back again. So I'll just go back to my Chrome tab for a second. Okay, so just give me a second. I just need to go back to the AAA thing. So just sit tight, everybody. Just give me a second. These things take time, a little bit of time anyway. So I think what happened was I was logged in and I didn't do anything, and so it logged me out. Okay. Okay, I think I'm back. So let me go back to my Maple window. Okay, so this is all the calculus and stuff that I did this morning. Okay, let me just do this again. I'll just compile. Okay, hopefully that's got me going in the right direction. Yeah, okay, all right. So take two. Here comes the algebra again. All right, so you can see Maple has calculated 5 roots. Okay, they're going to be in conjugate pairs or just real valued. And then the challenge is, well, we want to find the root with the biggest modulus here. Okay, so what I've done now is I've said, okay, on that list R1, let's calculate the moduli, okay, of each one of them. And you can see these are the different moduli for each of these solutions. Okay, and then the last thing I want to do, or I can also do it by just looking at it, is to find the biggest one. Okay, so you can see that I've just put in max there. That's going to be the biggest one, and I mean this one and this one, they're the same. So there you go. So I take that, I copy it, I paste it, and I put it into my little Mobius box. Okay, so let's go and do that. So I've done that over here. Okay, and how did we do? Ah, thank goodness. It's all green. It feels really good when the green comes up, doesn't it? You press the how did I do when the green comes up. It's really good. Okay, so questions on that one, people? Questions. Now is the time to ask questions. What do you think? Is there anything that's not clear there? Is there anything that you would like me to explain a bit more? Let me know in the chat. There are 14 people here. So that means the tilde means that we're applying the command to a list. I think, Denzel. I think that's what it means. Okay, so we don't want just to do it to one of them. We want to do it to everything in the list. Okay. So let me see if I can find some information. Yeah. So it's like you're applying it to a set. That's what it really means, Denzel. Does that kind of make sense? Yeah, Tom, of course. I can go back to Maple. I'm going to go back there anyway, buddy. So when because I think the good question, William, I think the default setting for fsolve is something equals 0. Does that make sense, William? I think that's the default setting. If you don't set it to anything, it'll just assume you want to find the zeros of it. Does that make sense? because sometimes, yeah, no, it's good. If you want to do it, do it. But Maple, sometimes it just, interprets things on its own. Like when you graph or plot something, it just makes its own mind up unless you tell it. Okay, so let's have a look at the next question, and then I'll go back for Tom's. Okay, so here's another almost identical one, right? You've got a polynomial. Enter for the largest principal argument this time. Okay, the largest principal argument. So you want to find the roots and find the biggest principal argument. Okay, so that's slightly different to the one that we were looking at before. All right, so let's go over to the Maple window. Okay, Tom, this is for you. Here comes the algebra. Right, so this is the one we did before. Now, don't worry about this. This is just some code that I put in to calculate the argument of the previous example, but we don't need it for this one. Okay, so take your screenshot, Tom, and then I'll just move on. Cool. All right, thanks, Tom. All right, so here is R2. Okay, so R2 is going to be a list, and you're looking at the solution to this polynomial equals 0, and we're including the possibility of complex valued roots or solutions. Okay, so here they are, and then all I've done there, instead of using abs for the moduli, I'm just applying the argument to everything in the set or the list R2. Okay, and then the matter is just, well, let's just pick out the biggest value here. Okay, so you can just pick it out with your eyes, or I just use the max command and it gave me that. Okay, so remember that as a default, Maple gives you the 10 significant figures accuracy. So when you copy and paste this, it's fine. It satisfies the accuracy that the practice test asks you for. Okay, so if we copy and paste this over to our Mobius page, I get something like this, right? And how did we do? Oh, it's still green. Whew. Oh, it just feels so good when I press that and it comes up green. I hope you feel good too. Okay, so any questions there so far? So they're two very similar problems, but they just ask you for slightly different things. Okay. All right, so let's move on to the next one. Okay, all right. So here is a complex numbers question. I don't think they really want you to do this in Maple, but you can do it. You can do this in Maple. You can also just do it in the text box, right? Because I'll show you. If you look down here, you can see that's actually not simplified. But if I press see how it simplifies it for me? So sometimes you can, same with this one, right? That's not actually simplified, but if I press the button, it simplifies it for me. So sometimes if you want to, you can just enter the non-simplified forms into the boxes and it'll actually simplify it for you. But let's go through the different parts. All right, you've got two complex numbers and Z and W. And the modulus of Z is 6, and the principal argument of Z is pi on 4. And the modulus of W is 2, and the principal argument of W is pi on 3. So both of these complex numbers sit in the first quadrant of the complex plane. Okay, All right. So who can tell me on the chat? We got 15 people here. Why is the modulus of the product 12? Who can tell me? You can turn on your microphones too if you want to. Everyone can speak. Who can tell me why is the modulus of Z times W 12? Exactly. Exactly. So Williams put in 6 times 2. That's good enough for me. Okay, that is good enough for me. In fact, you can just, if you wanted to, you can just go, oops, don't do that. Oh, okay, you can't check that one. All right, I want a number, fair enough. Okay, so 12. And what about Z, the modulus of Z divided by W? Well, that's 6 divided by 2. Okay, yeah. So, yeah, that's pretty easy too. So let's check our answers. Oh, it feels so good. All right, so for this one, the principal argument of Z times W, who can tell me on the chat, when we multiply a complex number, what do we do with the angles? Can anyone tell me? What do we do with the angles? When we multiply, yeah, we add them together, Vrudant, well done. Okay, so here you can see I've just added pi on 4 and pi on 3. Let me see if that works, if we just put it in like this. See if that works. Yep. Yay. Okay. So there you go. So multiplying, we add the two angles. Dividing, we minus the two angles, right? So it'll be pi on 4 minus pi on 3. Okay. So that's pretty easy. You don't even have to simplify them, which is nice. Okay, what about the modulus of Z to the power 4 times Z to the power of W to the power 2? Well, that's just the modulus of Z to the power 4 times the modulus of W squared. Okay, so that's what I've done here. And yep, how did I do? Feels so good. Okay, in this one, you want to take 6 to the power 4 and divide it by 2 to the power 3. Okay, easy. And then this one, we want to multiply the argument of Z by 3 and add it to the argument of W times 4. Okay, so if I was to do something like this, let's say I multiply this angle by 3, so I'll get 3 times pi on 4, and I want to add it to this angle times 4, and I can simplify it here. So it's 25 pi on 12. That's not the principal argument because it's not between negative pi and pi. So if I simplify this, it'll become pi on 12, right? Yeah. And the same with this one. Okay, so are there any questions for that one? You don't really need Maple for that. I mean, you can do it, but you're gonna end up coding a lot of stuff, and it's gonna take longer than probably doing it in your head or doing it on paper. So let me know if there are any questions for that one. Are there any questions? Okie dokie, let's move on. All right. This is an interesting question. Let P of X be a real polynomial of degree 8. So that means the coefficients are all real numbers. You are given that P of 8 plus 3i equals 0. Find a quadratic factor, a real quadratic factor, and enter it in the box below. Okay. All right. So who can tell me? Who can give me another linear factor just from that information? Who can write down a linear factor of P? Who can write it down in the chat? 16 people here. Come on, people. Let's go. All right. Yes, that's right. So Vrudant and Aichen, thank you. How do we know this? Because if this is a factor, then the conjugate is a factor. So 8 minus 3i is also a factor. Okay? Yep. So, and as Vrudant has put in the chat, that's the way you would actually get the polynomial that's there, the quadratic thing. Because if you have two factors, then the product of those two factors is also a factor. So you probably don't need Maple here, but let me just show you my Maple window anyway. Okay. So here it is. All I've done there is I've coded that in and I've used the simplify command. Okay. So if you're a bit worried about it, you can always just put that in and use the simplify. So there's one root and there's the conjugate, which is another root. Okay. So can anyone tell me what is the name of the theorem that is being used here? What is the name of the theorem for this question? What is it being related to, really? Anyone? Who can tell me? Conjugate root theorem, it starts with an F. I'll give you an example. In this course, we call it, we give it a special name. Anyone? Factor theorem. Okay, I think if you look in your notes, you'll see the factor theorem. Okay, so that one's pretty easy. Let us continue. All right. Okay, so if we go to next. All right, so we're on to matrices. So I don't think you need any Maple for this. Okay, so you've got a matrix. It's augmented. When following the standard Gaussian elimination algorithm, they want you to identify the next operation. Okay, so you can see here, that's a leading row. That is row 3 is, row 4 is not a leading row yet. It's a leading row, but we haven't got it down with that nice row reduction yet. So can anyone tell me what are we going to do about this 2 and what should the next operation be? Who can tell me? Who can tell me on the chat? 17 people here. What do you think our next operation should be? 2 row 3 minus row 4. Not so sure about that one. Oh, so you're saying, yeah, I think that's what you're trying to say, William. So row 4 becomes row 4 minus 2 row 3. Yeah, you can write it a few different ways. Okay, so is that what I've done? Yes. How did we do? All green. Okay, so that's just Gaussian elimination. No need for maple, right? No need for maple. Okay, so now it's getting a bit harder. Let me just make that a bit smaller. I know it's very small now, but I'm trying to fit the matrices in. Okay, so for each of the following augmented matrices, decide whether there's no solution, one solution, or infinitely many solutions. So let's have a look at matrix A. Okay. So I've said the augmented matrix A represents a system of equations with no solution. Why is that correct? Does anybody know? Why is that actually the case? Who can tell? Rudant, tell me a little bit more, buddy. What do you notice about the last row? Yeah, 0 equals 7. The bottom row sort of tells you, but also the very right-hand column is leading, right? That's a leading column because the 7 is the first non-zero entry in the bottom row. Okay, so definitely there's no solution for that one. What about part B, people? Matrix B. I've said the augmented matrix represents a system of equations with infinitely many solutions and 2 parameters. Okay, so how did I decide that? Does anybody know? How did I decide that? I mean, I'm correct, right? If I go, oh, hang on, I just clicked on it. Okay. The augmented matrix B represents a system of equations with infinitely many solutions and 2 parameters. How did I actually work that out? What is the thought process? Who can tell me? Who can tell me? Come on, 17 people here. Hello? Come on, 7 variables, but only 5 equations. Not a bad idea, Steve. Try to think about the columns. Just let me close this door. Think about the columns. How many leading columns are there? And how many how many are non-leading? I guess that's what I'm looking at. So, I can see this column is not a leading column, right? That's definitely not a leading column. And this column, or this one, is also not a leading column, okay? So what that tells me is that, Rudan, you don't know, have you not talked about leading columns yet in lectures and non-leading columns? I mean, I'm assuming that you've seen this in lectures, right? You haven't reached there yet? Really? Let me just do a quick poll. I have just put this. You just start that. Okay. 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 All right. So it seems a bit mixed. So let me bring it up. I'll bring it up in the the course notes. Let me just have a look here. Okay. So let me just have a look. I'm just looking it up here in front of me. Okay. All right, so let me just go back here and I'll share this with you. Okay, so this is page 149 in your notes, okay? So the system has no solution if and only if the right-hand column is a leading column, okay? So let me explain what that is, because I think that's important, okay? So if you look at the first example, the first matrix, all right? So this column is a leading column because if we look at all the rows, this 7 is the first non-zero entry in the bottom row, okay? Let me say that again. This last row column is called a leading column because it contains this number 7, which is the first non-zero entry of the bottom row. Okay, so let's look at this one. Does this column contain the a non-zero entry of row 1? Yes, there it is. Let's look at row 2. There's the leading entry of row 2. It's -1. There's the leading entry of row 3. There's the leading entry of row 4. Let's look at row 2. Does row 2 contain the leading entry of some row? And the answer is no. So row 2 is not a leading column. Okay? Similarly, there's another non-leading column in there. And so what that means is the variable associated with that row, and say that row, it could be anything. Okay, so that's what you mean. That's what we mean when we talk about two parameters, right? So is that becoming a little bit clearer? Because it's something that students struggle with because there's a lot of terms going on. But the idea is to look at the rows and identify the non-leading rows, and they're non-leading if they contain, if they don't contain if they don't contain any leading row entry of a column. Okay, so let's have a look at the third matrix. Let's look at all the columns. Is the final column leading? No, because it doesn't contain the first entry of any of the rows, first non-zero entry. Okay, this column contains the first entry, non-zero entry of row 1. This column contains the first non-zero entry of row 2. This column contains the first non-zero entry of row 3. This column contains the first non-zero entry of row 4. So C has a unique solution. Okay. How did we do? So good. All right, last question. I think this is the last question. Yes. So let's go back to Maple. See if we can work it out. So you've got two implicitly defined curves from these relationships. Find the number of intersections of these curves for x between positive and -10 and y between positive and -10. Okay. So what they want you to do is use the plot command, okay? The implicit plot command. Okay, so let's go over to Maple and we can have a little look. Okay, so you can see here, the first thing you want to do with this is to do the plots calling sequence, right? So I'm just putting it into the chat. So that gives you a whole bunch of stuff. And let me just see if I've done it up here. Yeah, there it is. So you can see there, I've called the sequence plots. And the most important thing, you can have, polar plot or whatever, is the implicit plot. Okay, because these are sort of implicitly defined equations, I guess. Okay, and so last thing we want to do, implicit plot them. The square brackets are there because we're kind of putting together a little list of two curves that are going to be on the same set of axes. Okay, and so I've put the restrictions on the x and y in line with the restrictions in the question. And you don't have to do this, but I've just chosen two different colors because it's easier to see what's going on here. Okay, so if you look at this closely, you can see, well, there's going to be 2 points where these things touch. Now, if you can't quite see that, you can always just change the things to give you a clearer look, right? So if I do that, you can kind of see, oh, right, that's definitely just hitting in one spot. Okay. Same on the other side. Okay. So based on the picture, we will just say 2 solutions, right? So there it is. How did I do? I'm not going to submit the assignment. I'm going to quit and save. Okay, people, so that is the algebra questions done and dusted. So on the chat, Rudant, what is we are asked to find the solutions? Well, there's no evidence you'll be asked to solve those solutions. What makes you think you'll be asked to solve them, Rudant? What makes you think you'll be asked to find the solution? Well, you probably can, right? But yeah, but I mean, yes, I'm sure you'd be able to solve them. But yeah, I mean, that's not what it's asking for, really. So yeah. Okay. Any other questions? Because we just about finished the algebra. There seem to be a lot more practice questions for the calculus than the algebra. I don't really know why, but yeah. So yeah, that's it. So yeah, so why don't we stop the recording and then we can have a bit more of a chat. So I'm just going to stop the recording now.